So with circle geometry, the basic is our circle. So you're going to get a plane. On your plane, there could be a circle, bad circle, and then the circle has a center with coordinates we're going to put today, A, B. Now, from the center to any point on the circle, that would be your radius. Now, the equation for a circle will be x minus a being the x coordinate of your center squared, plus y minus b squared equals to r squared. Okay, now this is the usual format that the equation of your circle is going to be in, but they might ask you to write it in the format ax squared plus bx plus c is equal to 0. Now, there's a few other equations that we need to know as well when we're doing circle geometry. The first being the equation for gradient. Now, to work out your gradient, or in short, m, we work out the change in y over the change in x. Thus, meaning y2 minus y1 divided by x2 minus x1. Then the next one is our midpoint formula. And this you can work out by adding your x values of the 2 points that you want to find the middle of, divided by 2. And then exactly the same for your y. And that's how you're going to find the midpoint of a line. The last little one we need to know is that when lines are perpendicular, meaning that they meet at a 90-degree angle, we can say that the gradient of the one line multiplied by the gradient of the second line will be equal to -1. Then we have 3 common rules when it comes to circles. The first one is the chord rule. So if we have a chord in our circle and we work out the perpendicular bisector of that chord, meaning that we're going to use perpendicular and the bisector, meaning the midpoint, that bisector is going to move through the center of our circle. The second rule is our tangent. Now, a tangent is a line that touches the circle on only one point. Now, our radius, in this case, will be perpendicular to our tangent line. Then lastly is our circumcircle, and that is when we have a triangle within our circle and the corners of the triangle touches all the parts of the circle. If this triangle has a 90-degree corner, it means that the hypotenuse of the circle will go through the center of the circle. Okay, so that's just a quick recap on everything you need to know on circle geometry. So I'm going to go through a few of the questions that you had for homework and just explain how you can work them out. Just going to open the document that you sent me. So in the first question of your homework, it says that the coordinates of point A, B, and C are 6, 6, 4, P7, 14, 18, respectively, where P is a constant. The line AB is perpendicular to the line BC. So you here have 2 lines, a line AB that's perpendicular to BC. Now, the coordinates of A is 6, 4. Of B is P7, and of C is 1480. Your first question then asks, given that P is smaller than 10, find the value of P. So we know that these 2 lines are perpendicular, meaning that the gradient of AB multiplied by the gradient of BC should give you -1. And we can work it out that way. So the gradient of AB will be the change in y, meaning 4 minus 7, divided by the change in x, 6 minus b. multiplied by the gradient of BC, which is the change in y, 18 minus 7, divided by the change in x, which is 14 minus b. And this should be equal to -1. We can then multiply those two values. So we work out 4 minus 7, work out 18 minus 7, and we multiply them to get -33 divided by, and we multiply these two as well. I'm just going to keep them in brackets because it's more simple that way. So now I want to get rid of this whole fraction thing. So I'm going to multiply this side by 6 minus p, 14 minus p. And what I do on the one side, I want to do on the other side as well. So what I'm going to get now is -33 is equal to -6, 6 minus p, 14 minus p. I can divide by -1 on both sides to get rid of the negative, and I get 33 is equal to 6 minus p, 14 minus p. The next thing we're going to do is now we are going to work out our brackets. So let's just write down our 33. We multiply in, so now we have 14 times 6, that's going to give us 84, minus 14p minus 6p plus b squared. We can bring the 33 over, and then that would give us p squared minus 20p plus 51. And then we can factorize to get our two brackets again. We're going to end up with pp and then minus 17 and minus 3. Then we can just say that p minus 17 could be equal to 0, or that p minus 3 could be equal to 0. So p could either be 17 or p could be 3. Now, obviously, we know that it's not 17 because they said that p is smaller than 10. And that's how you work out A. Now, with question B, they say the circle passes through points A, B, and C. So it means that our circle now, and I'm going to try my best to draw this, is going to look something like this. So now we can already see from our notes that this would be a circumcircle where we have our 90 degrees and AC will go through the center of our circle. It's one of the rules we need to study. They then say find the equation of the circle. And this is pretty easy because we recognize that it's a circumcircle. We can say that the midpoint of AC is the center. So we work out the midpoint of AC. And this is going to give us, so we say x, the first x plus the second x divided by 2. Then y, first y plus the second y divided by 2. And this is going to give us 10 and 11. So this is our A and B. We can then just add it to our little circle equation. So remember our circle equation is x minus a squared plus y minus b squared is equal to r squared. We're going to put it in. We're also going to put in an x value. For this x value, I went with 3 For this x value, I decided to go 3 and 7, which is point B. So I'm going to say 3 minus 10 squared plus 7 minus 11 squared is equal to r squared. This gives me minus 7 squared plus minus 4 squared. Oopsies, equals to r squared. I can work it out, and I'm going to get r squared is equal to 65. That means that my equation for the circle would be x minus 10 squared plus y minus 11 squared is equal to 65. Then the last question in this series is question C. Now question C says find the equation of the tangent to the circle C, giving the answer in the form dx plus ey plus f equals to 0, where d, e, and f are integers. Now, if we talk about a tangent, we know from our little circle rules that the tangent is perpendicular to the radius. So if we work out the gradient of the radius, we can work it out by saying the change in y over the change in x. So remember, we now know what that point is. So we can, I'm going to just write it in so we can remember it. It's 10, 11. Okay. So the change in y is 18 minus 11 over 14 minus 10. And that's going to give us 7 over 4. Now to work out the gradient of the tangent, we're going to switch around the fraction, just add a negative. The easiest way to do it. If you're not comfortable in doing it just like that, you can still do the m radius times m tangent should be equal to -1. Okay. So now we have the gradient of the tangent. So now we can substitute it into our straight line formula. So we can say y is 18, and I decided to use 18 as C is on that straight line, equals to my gradient, that is now -4 over 7, multiplied by 14 plus C. Then I can just work it out, and I'm going to get C is equal to 26. Ta-da! Now I can write down y is equal to -4 over 7 x plus 26. But they did ask us to give it in the form of dx plus ey plus f equals to 0. So I want to put everything this side. So I'm going to say 4 over 7x plus y minus 26 is equal to 0. And that is going to be my answer. Then we have the next question. Question number 2. Question number 2 is on the more of the complicated side, but we'll slowly go through it together. Let me just rub this out quickly. Just quickly cleaning my board. There we go. Okay. So, the next question that you sent me. So, in this question, they do give us a schematic. The schematic is a tiny circle. Oh, excuse how my circles look. And then a big circle. And then your axes. They tell us that this is circle P and this is circle Q. Then they say that there's a tangent line here all the way through, and it basically touches at A. Then they say the diagram shows circle P with a center 0, 2. So let's write it in. and a radius of 10. So I'm going to put the radius down. 10. And the tangent to the circle at point A with coordinates 6, 10. It also shows a second circle Q, that's a smaller circle, with a center at the point where the tangent meets the y-axis and the radius of 5 over 2 pi 5. So they say here, where the tangent meets the y-axis is the center. So it's right there. And then the radius, I'm just going to do that because there's not a lot of space, is 5 over 2 pi 5. Okay. Then the first question that they ask is write down the equation of circle P. And this is very easy because for circle P, they already gave us the radius and the midpoint. So if we remember our normal circle equation, which is x minus a squared plus y minus b squared equals to r squared, we can just fill it in. So we have x minus a would be 0 squared plus y minus b would be 2 squared, and these I get from my center coordinates, equals to r squared would be 10 squared, so that is 100. We can then just simplify this equation a little bit to look a little bit more pretty. We can say x squared plus y minus 2 squared equals to 100. And that would be the end of question A. Then we have question B. Now, question B says find the equation of the tangent to the circle P at A. So that one. So we know that the gradient of the tangent would be, if we multiply that with the gradient of the radius, we would get -1 because the radius and the tangent would be perpendicular always. So let's work out the gradient of the radius first. And we can work this out by doing the change in y and the change in x. So it will be this line from the center to A. So the change in y would be 2 minus 10 divided by 0 minus 6. And that would give me 4 over 3. Now, if we work out the gradient of the tangent, we know that the gradient of the tangent multiplied by the gradient of the radius would give me -1. So I can either just flip it and put a minus on, so -3 over 4, or I can work it out. I'm just going to show you how. 4 over 3. There we go. And that would be the gradient of my tangent. I can then just substitute it in my straight line equation because I know that my tangent would be a straight line. And I'm going to add the a coordinates to my x and my y. So I have 10 equals to my gradient multiplied by 6 plus c. I then get c is 29 over 2. Weird, but yes, that's what it is. So y is equal to -3 over 4 x plus 29 over 2. And there we go. That would be the equation of your tangent at P. Then we have the third question. And this question is on the bit more difficult side. So they say find the equation of circle Q and hence verify that the y coordinates of both of the points of intersection of the two circles are 11. So they want us to work out the equation of circle Q, and then they want us to prove that both these intersections where P and Q meet, that the y coordinates are 11. So let's first do the equation of Q. So we know that the center of Q is where the tangent cuts the y-axis. So I can use this equation. I'm just going to say C down here. I can use this equation and say it is where x is equal to 0 because x is 0 where it cuts the y-axis. I'm then going to get that my y is 29 over 2. So my coordinates of my center would be 0, 29 divided by 2. There we go. And we can use this to put in our circle equation. So remember our circle equation, x minus a squared plus y minus b squared is equal to r squared. So we have our radius, we have everything. Okay, so we have x minus our a is 0 squared plus y minus b, which is 29 over 2 squared, is equal to our radius, which is 5 over 2 square root 5 squared. We can then just simplify this and we can get x squared plus y minus 29 over 2 squared is equal to 125 over 4. There we go. And that would be the equation of my circle Q. But we're not done. They also said that we now have to verify that both the points of intersection of circle P and Q are 11, the y coordinates. So we can say that I think the easiest way to do this would to be to get circle, let's say P here, the circle P, get x squared alone, and then for circle Q here, get x squared alone. And here we're going to say, okay, if x is equal to x, that means that I would get, sorry, this means that I would have 100 minus y minus 2 squared should be equal to, and then this side, which is 125 over 4 minus y minus 29 over 2 squared. There we go. Now what I want to do is I want to work it out. So I'm going to put my 100 and my 125 on one side, and I'm going to take my y over to that side. Let's do it a bit different, just to change it up. And I'm going to take my 100 to that side. And then I'm going to bring my y over to this side. So I am going to end up with negative y minus 2. And I'm going to expand my brackets. Bring this one over, becomes a positive. Equal 125 over 4 minus 100. We can then simplify this part. And that means that we're going to have y squared. Okay. Let's put the negative there first. Y squared minus 2y minus 2y plus 4 plus y squared minus 29 over 2y minus 29 over 2y plus 241 over 4 equals to 125 over 4 minus 100. That's going to give me negative 275 over 4. Oh, this is funny numbers, but I'm sure we're going to come right. So now we're going to multiply in that negative. So we're going to have negative y squared minus plus 4y minus 4 plus y squared minus 29 over 2 plus 29 over 2 gives me 29y. 29y plus 241 over 4. There we go. What a confusing bit. Okay. So now we want to get that one cancels out that one. Then we have 4y. Okay, so we're going to have on this side 4y. So it's negative 25y. And then let's put the 4 on the other side because remember it's equal to, I brought it up, 0. Okay, so this one and that one, meaning that it would be plus 275 equals to 0. So let's take that one over. Minus 25y is equal to negative 275. So y is equal to 11. Woo! That's a lot. A lot. But it's okay, we got it. Ooh, interesting. Okay, so here we just worked it out. We got it going. Okay, so let's look at the let me see what is the last question. I think there was a last question. Find the coordinates of the points of intersection of the tangent and circle Q, giving the answer in third form. Okay, coordinates of the point of intersection of the tangent and circle Q. So that is where the tangent, that one we had at A, and circle Q meet. Okay, so we have the equation for the tangent. It was this one. And we have the equation for circle Q. It was this one. So what we're going to do is we're going to take the equation of the tangent and just substitute it into the equation of the circle. I don't know how I'm going to do this, but I need more space. Yeah, so I'm going to rub out this. I'm pretty sure you drew this, and it's in your book in any case as well. I just need more space. Okay, so that was A, B, C, D. Okay, so we're going to have our equation of our circle, which is x squared plus y minus 29 over 2 squared is equal to 125 over 4. Okay, so now in this y, we're going to put our tangent. So we're going to have x squared plus, I like shaking up my brackets when I use more than one. Here's my tangent, so I'm going to have negative 3 over 4x plus 29 over 2 minus 29 over 2 squared is equal to 125 divided by 4. Okay, let's simplify. X squared plus negative 3 over 4x plus 29 minus 29 is just going to cancel each other out. Squared equals to 125 over 4. Okay, we can just put that square in. That gives us x squared minus 3 over 4x. Oopsies. Almost made a simple mistake. That square needs to go to both sides. So that's going to give us a positive 9 over 16 x squared is equal to 125 over 4. We can add this together, and that's going to give us 25 over 16 x squared is equal to 125 over 4. Okay, let's divide this side by 25 over 16. What we do on the one side, we have to do on the other side. And a little trick, like a really a lower grade trick, but if you don't have a calculator, this big divide, we can also say that it's 125 divided by 4 multiplied by 16 over 25. So we can turn it into a multiply if we switch around our fraction. This is going to leave us with x squared is equal to 20, meaning that x is equal to plus minus 2 square root 5. And the reason I say plus minus is because I added a square root to both sides, and if I add a square root, it can either be positive or negative. Okay. Now that's our x. Now we're going to add our x to our tangent equation. So we have y is equal to negative 3 over 4. This is where my x comes in, plus minus 2 square root 5 plus 29 over 2, which means that y can either be 29 plus or minus 3 square root 5 divided by 2. And that is third form. So I'm going to leave it right there, just the way it is. I know it's late and I'm kind of falling asleep here. But if you have any questions, don't hesitate to send me a WhatsApp and I'll see how I can help you the best I can. Yeah, thank you. Bye.